Hi everyone, welcome to today's webinar, How to Automate Color Control with an Inline Color Measurement System. Presenting today is Tim Mouw, our Applications Engineering and Technical Support Manager at X-Rite. I'm Robert Grotans, the Global Digital Learning Manager, and I'll be moderating today's webinar. I just want to go over a couple of things before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions during the presentation, please feel free to use the questions function on the GoToWebinar panel, and we will have some time at the very end of this webinar to answer a few of your questions. Finally, this webinar will be recorded, and we will follow up with an email after this webinar with a link to the recording so that you can watch it again. So with that, I will turn it over to Tim to get things started.
Thank you, Robert. Welcome, everyone. As Robert said, my name is Tim Mouw, and I'm here to share with you today some highlights about what it means to automate color control using what we call inline measurement. We're going to dive into that, talk about what that means, and what it's like to have real-time color measurement in a production environment. So let's begin. To start with, our agenda. Okay, we're going to define what we mean when we talk about an inline spectrophotometer. We will then talk about how do inline spectrophotometers compare to what we would call a traditional spectrophotometer. Then we'll talk about the benefits of inline and some of those, and how those benefits can lead to a return on investment. And finally, we'll talk about a variety of applications for inline, where they can work, what can they do, and all of that. So we'll dive into each of those separately. The goal of this webinar is it's not going to last for a terribly long time, 10 to 15 minutes, to give you enough information, hopefully to make some assessments on whether inline might be of use for you. And then, as Robert said, we'll have some time for questions at the end. So let's talk first about what's an inline spectrophotometer. And maybe I should begin. I just thought of this. I didn't actually put it in my presentation. Before I start defining what we mean by inline, I should probably make sure we all understand what we mean when we say spectrophotometer. And some people might just call that a spectro. That's a shortened version of that word. Is simply an instrument that shines light on an object and uses the light that interacts with the object to measure its color or other things, right? So that's what we're talking about, color measurement devices for the most part. And inline, what do we mean by inline? Well, it's bringing color measurement directly into the manufacturing process. So putting it out on the production floor. To do that, it means that we've got to have a device that's built for a harsh production environment, right? So you'll notice here's a picture of one of our inline devices. You'll notice it's built for a production environment. It's not a laboratory device, although it could be used in a laboratory, but it's built to withstand the harsh environment in production. Many of these devices, for example, include some connections to air pressure to help keep their optics clean, because a production environment can be dirty. And so we do things to help keep them clean. Many of them have built-in internal calibration things that are happening, so we don't have to worry about those things getting exposed to the production environment. So they're built for that environment. They can connect via OPC to a production system. So for example, the production system can tell the inline measurement system what it is it's going to be measuring, to recall a standard, those kinds of things. They can be fixed or traversing, and I'll show you a couple of pictures here. So the one on the bottom left, that's an instrument that's in a fixed position. The device is going to stay right where it is. The material, that orange material underneath that looks very yellow where the light of the device is shining, the material is moving underneath the device, and the device is measuring in a single spot. The one on the right is a traversing system, and so the device is kind of far away from us, and it will slide, if you will, along this traversing beam and measure across this, this happens to be a coil of metal. And what a traversing system allows us to do is not just measure in a single location as the material is moving across, but to measure left, center, and right, for example. So we measure both edges and the middle, and it can traverse back and forth as the material is moving, measuring in multiple places. So we have the ability to do that with a traversing system. Inline spectrophotometers typically have automated measurement triggers. They can be set to measure based on time. They can have be connected to sensors and systems that allow them to measure based on how many feet or meters of material go by, measure every X number of meters. There are a variety of different ways that we can automatically trigger the device as to when to take a measurement. And the device, of course, can automatically have output, right? It can be visual to something like a light tree, right? Where maybe the lights, hopefully, most of the time you're running production, that light's green, meaning everything's good. But if your color starts to drift, it goes yellow. And if you get to a failure state, the light goes red. It can be hooked up to audible feedback. It can even do things like stop, do a full stop if it reaches a critical point. So those outputs allow us to do those kinds of things. And then, of course, we also have software with live trending of color data. Let me just show you a quick screen grab of that. So this is an example of what you would see. If you're familiar with LAB color space, there's essentially 4 trend graphs here. The top one is lightness or darkness, and you can see the little bars are either lighter, white, meaning the measurement was lighter than the color standard, or they're dark, meaning it was darker. The middle is red or green for A. The next one down is yellow or blue for B, and then the bottom one is measuring a total color difference at delta E, and each one of those bars represents another measurement. So you can have a monitor sitting where you're able to just see your production as it's going and evaluate what you're doing. And we'll talk more about this a bit in detail in a moment. So just to give you a picture, on the left are a couple of inline devices. Again, you can see they look different because they are built for a production system, right, for that kind of an environment. Versus on the right, we've got a benchtop CI 7800 and a handheld CI 64 that are more laboratory devices. Now, those laboratory devices have advantages because they've got things they can do. The flexibility of the things you can do with them and so forth is good. The CI 64 being portable, right? I can carry the device around. I'm not going to carry around an inline device, right? But they are also really more laboratory focused kind of devices, where the instruments on the left, the ERX 130, the ERX 56, a couple of examples of inline devices that are built to be in that environment and work well. So what's the difference in functionally? Well, let's talk about measurement type. And I say type meaning how does the instrument measure the sample? Well, with inline, we are doing non-contact measurement. And depending upon which device we're talking about, and which inline device we would be considering will depend on what it is you're measuring and the application and so forth. But it's a non-contact measurement that can be anywhere from a ½ inch away from the sample to nearly 12 inches away, or 12 to 300 millimeters away from the sample, right? So it's non-contact. Traditional instruments have to contact the sample. Right? We have to put the sample against the device, take a measurement. Now, there are some non-contact laboratory instruments as well, but one of the advantages here, of course, for inline is that if what you're measuring isn't completely cured, right? No issue. And obviously, if we're going to measure something that's moving, right? Like the coil we saw earlier, if that coil is moving and the instrument is taking a measurement of it as it's moving, if we made contact, we would be causing all kinds of damage to the product. So non-contact is the first major difference with inline. Second is aperture sizes. So inline measures from, again, depends on which inline device we're talking about, from 1/2 inch to 3.5 inches in diameter. That's the measurement size, and we have it there in millimeters as well. Compared to traditional, which is a smaller aperture, down to 1/4 inch, and the maximum we go is a 1 inch, right, 25 millimeter. So smaller areas. The advantage the larger apertures give you with inline is, of course, again, things are moving that are being measured. So that helps. The larger area helps with that. And you might be measuring something like carpet, for example, right? Where the color you're measuring isn't a solid homogeneous color. And so the larger area you're measuring, right, the better the instrument and the measurement will be at capturing the overall color, because it's averaging together, if you will, a larger area, 90 millimeters on the high end. Okay, that's the second difference. The third one we want to talk about is measurement location, and this one we'll dive into quite a bit deeper in a moment. But by location, what I'm talking about is, where are we doing it, right? What do we have to do to take a measurement? Well, inline, it's measuring in production while the line is running. We're not stopping anything. Traditional, if I want to do a traditional measurement of something from my production line, I have to pull a sample from production and bring it to the device, which either means I'm going to get a sample after all of my production work is done, right? So it's at the end of the line, already off the line, so to speak, or I have to stop my line to pull a sample and then start the line back up. Though that advantage with inline is a major advantage. We'll talk more about why in just a moment. So let's talk about the benefits and ROI. I'm not going to speak about ROI in numbers, but I'm going to talk about what are the things that you're gain with an inline system that really lead to covering the cost of such a system. First one is automated measurements. So as I mentioned earlier, the instrument can be set, right? It's in place, it's automatically triggered or timed or whatever to how often it's going to take a measurement. It can be traversing, sitting still, whatever, but it's all automated. So your instrument doesn't take coffee breaks, go on vacation, have sick days, although maybe once a year or so it might need to be, have maintenance done on it and those kinds of things. So it obviously has that requirement, but otherwise it's there measuring 24/7 as needed to do the kinds of things you need to do to evaluate your production environment. Okay. Second one is that it will reduce production interruptions. So if the situation is such that you need to pull a sample to take a measurement, right? Like you mentioned, you're either going to stop your production to pull a sample. Well, that's an interruption. That costs you money, right? Or you're going to pull it a sample from the end of your production run. Now you're checking color, and you're checking color and how much product has gone by that might be bad. Let's say you pull a sample and you go test it. You say, oh, color's off. Well, how much bad color have you produced in the time that it took you since you last checked it, right? So the fact that you're doing automated measurements during production, right, can really reduce your waste and how much off-color material you produce. That's really where the ROI is coming in. It also can help you if you're doing color changeover. So if you're doing extruding something, right? Could be any of these continuous flow kind of systems, right? Carpet, coil, extruding vinyl siding, extruding vinyl molding or plastics of any kind, right? You do a color changeover, the device, since it's measuring in line as you're doing the changeover, right, can tell you quickly as soon as you've reached, yep, okay, my color is good. I'm producing my first color. The color is good. The color is good. I'm switching over to the second color. I'll know when I need to cut off because now I'm starting to get color that's off because of the changeover, right? I get to the new color. I'll know immediately when that new color has reached, that new batch has reached its color that I'm trying to achieve, and off I go. And so I eliminate how much waste I have, waste of time and material in color changeover, because I'll know when to stop and when to start calling my color good. The ability to check multiple directions for color consistency. And what I'm talking about here is if I have a stationary measurement in line, right, I'm going to measure the color as it flows by, so to speak, linearly. But if I have a traversing system, I can also check it left to right as well. So I'm going in 2 dimensions, so to speak. Why is that important? Well, while it's important that you continuously make the same color as it's flowing through production, you also have to be aware that the end use of whatever product you're making may have 2 pieces that get butted against each other. So you need the left side and the right side to be the same color, because someone might butt 2 pieces together and you need them to look like they're the same color. So you need color consistency, and you can check that with a traversing system. I think this one's a really key thing. Outputs to PLCs to drive corrective actions before color failure. Again, we're back to this light. So we have the ability to set up not only a pass-fail tolerance, but also the warning, right? So when is the light going to turn yellow, which is supposed to be turning yellow and letting me know, hey, you've got your color is starting to drift out before it starts to fail. So it's still okay. It might still be acceptable, but it's starting to approach being unacceptable. If I can know that, then I can take an action before I ever get to a red light. And we can see those corrective actions easily and quickly. So I'm going to show you another picture here from the software. So this is another trend of measurements, and you can look across and see, for example, you see the 3 red bars right here where my color was a little bit on the green side, and all of a sudden something happened and it went red, okay, for 3 measurements. Well, that probably was in a yellow state on my light, and it could have triggered me to do something to bring it back here before it got all the way up here. You see this green line at the top, that would be 1 unit, and maybe 1 unit is my limit, but I got notified when I got to over half of that number, above 0.5, and it's driving me to a correction. Same thing with the light or dark or the yellow blue, right? So gives me the ability to know when I need to take a corrective action, and I can very quickly see that those corrective actions are happening and that they are indeed impacting things correctly. And of course, it's never quite as simple as go fix one thing and then everything gets better, because sometimes correcting one item, right? For example, they might have done something to correct it being too light here. Okay, it started to drift too dark, and the correction they were doing to deal with the lightness might have affected the red-green, right? So it's the ability to see what you're doing, have the ability to interact with it, and know that your adjustments are going to correct your production. So applications, we're not going to go terribly deep here, but it's really just to give you some ideas. So first off, we've got multiple ways to measure. We've been talking about color, and we can measure reflective color. We can measure transmissive color and haze and gloss. I'm going to show you one other device here. This is the device that allows us to do transmissive color. You can see this kind of a C frame, we call it, where the product would actually flow in between. And so you've got a light on one side of the product and a sensor on the other. So if you're measuring, a film that's transparent, or you want to measure glass, for example, and you need to measure the light that's transmitted through it, you have the ability to do that, as well as measuring reflective color. And the transmission gives us the ability to do haze and so forth. And we can measure a wide variety of products. This is not an exhaustive list, but some of them I've already mentioned. Carpet, right? It's something that fits very well here because it's wide flowing product down a production line, measuring left, center, and right as we're measuring carpet. Films, as I measured, really extrusions of any kind, right? Coil coatings, paper, glass, even glass. We have devices that are built specifically to help with measuring glass that are mirror-like surfaces, but also to help measuring glass that are UV coated, right? We have the ability to measure the UV that's passing, amount of UV light that's passing through them to detect, are they meeting the needs of that UV coating on the glass. So there's a host more, obviously, things that we can measure with these devices. But our goal today was to introduce you to these products, give you some idea of what's available and what's possible. And with that, we will open it up to see if we have any questions. And I think Robert also would like to insert something here with a poll.
Yeah, while we wait for questions to come in, I am going to launch a poll question. If you would like more information or if you'd like to speak to someone, feel free to answer that question. And if you have a question you'd like to submit, please feel free to do so now.
Okay, I got one question here. So someone asked about extraneous light. It's always a question when we talk about non-contact color measurement, right? Does the extraneous or the ambient light have an issue when we have a non-contact measurement device? And the simple answer is no, right? The intensity of the light that we are using to illuminate the sample when we're taking the measurement is so significant that it essentially cancels out the impact of extraneous light. Now, I say that with a caveat. You could force a problem if you wanted to, right? If you took some really high luminance beam of light and focused it right where you're going to take your color measurement, it might have an impact on your color measurement. But for the most part, extraneous light doesn't have an issue, and in fact is something that's really well controlled by the means by which we both illuminate and measure these samples. Anyone else have a question?
Are you able to reshare your screen, Tim?
Did it stop?
I think so. Thank you.
Yep. Guess the poll must have done that to us, huh? All right, another question we have here, which is about number of measurements and lamp life and those, and those kinds of thoughts. So these devices are obviously made for a production environment, as I've mentioned numerous times, right? And made to take a lot of measurements. I think we have devices that will measure as quickly as one measurement per second. It's also why, so obviously that does lead to some wear and tear on the lamp, right? These devices are extremely precise in the fact that they're measuring every nanometer, which allows us to do really good compensation through calibration and so forth for the lamp as the lamp wears over time. And it's also why the vast majority of people who are using these, right, we've got service contracts and things in place where We're using that to properly maintain the device. We can certify the device, right? Where we're ensuring that it's still measuring correctly and all those kinds of things. So there's really good maintenance, just like anything else in the production line requires maintenance from time to time, right? The color measurement device does as well, and they're built to work that way and to handle that. All right. Not seeing any other questions. Give everybody one last chance should they come up with something, or as Robert mentioned, if you realize after the fact that you've got a question, you can certainly reach out to us via phone, via our website. We've got all of our connection stuff there if you're interested. We're more than happy to help you. And thank you all for joining us today, and wish you a happy and healthy day. Thank you.
Thank you, everyone.